Put yourself in a position for an interstellar shocker, considering the way that, according to a social event of specialists, Betelgeuse, the spellbinding red supergiant monster adorning Orion's shoulder, has recently exploded. That is correct. You heard that right. We are completely serious. Inside the accompanying 10 years, or a few numerous years, its magnificent repercussions will edify the evening sky. But how did analysts show up at this guarantee? Should we be concerned? May the James Webb Space Telescope get the extra of creepy, crawly squeeze? Today we're diving deep into all the most recent subtleties. Possibly one of the most recognizable stars in the night sky in the northern hemisphere during winter is the red supergiant star Betelgeuse. It's among the handful of stars that shine brightly enough for us to find. Truth be told, its blushing orange tone with the unaided eye makes Betelgeuse, by and large, the 10th most brilliant star in the night sky. Anyway, as you may already know, it's forever been known to fluctuate in brilliance. Part of the only justification for this is that Betelgeuse is in no way, shape, or form a normal star. Because of its immense size, assuming we were somehow fit for supplanting Betelgeuse with our own little sun, it would stretch out all the way to the asteroid belt and have a mass of a shocking numerous times that of the sun. It may come as a shock, but Betelgeuse is very energetic for a star with an age estimated to associate with 8 to 10 million years. In correlation, our own sun is a great deal more settled, with a normal age of around 4.6 billion years. This is because very giant stars like this consume rapidly through their nuclear fuel and go supernova quite quickly on geological timescales. This, moreover, infers they develop rapidly, and Betelgeuse may in all actuality have done that right before humankind's eyes. To sort out how analysts showed up at the end that Betelgeuse had recently exploded, it's fundamental to dive into the setting. The story starts around the 2nd century BC, when Chinese cosmologists mentioned a basic objective fact that Betelgeuse showed a specific yellow color. Quick forward to the focal point of the 2nd century AD, and the Greek stargazer Tycho Brahe described it as orangish or blushing, like how it shows up today. Similarly, archaic observers in the Middle East saw a tantamount shade. The request arises about how tones were named or found in the past. Anyway, for this case, there is a genuine chance that Betelgeuse went through a variety change within a couple of hundreds of years. It is possible that Chinese cosmologists saw Betelgeuse during its yellow supergiant stage, and over the years it advanced into the red supergiant stage. Given that individuals, by our tendency, are night sky watchers, you want to ponder the number of people across the globe who could see the star and notice the change yet left no records. All things considered, changes to a star like that probably accompanied an extensive variety of obscuring and illuminating occasions that aren't recorded. Imagine them gazing toward the night sky and saying, "Hey, didn't that star used to be more splendid?" Also, that's precisely what's been happening right now. Betelgeuse is a variable star. Anyway, it appears to change in accordance with some cyclic behavior. Starting in December 2019, Betelgeuse's brilliance oddly plunged predominantly, which was obviously detectable to the unaided eye. For those used to checking out the star, it was not its average self until mid-2020. Over time, it recuperated, and one speculation was that a portion of these cycles had orchestrated, making for a particularly profound dive in brilliance. At any rate, the perceptions made by the Hubble Space Telescope showed something rather specific. It created the impression that Betelgeuse had ousted a huge measure of burning material into space, framing an enormous dust cloud. This residue cloud, thus, darkened a tremendous piece of the star's light when viewed from our perspective. The change was very stunning. Betelgeuse, once considered among the 10 brightest stars in the night sky, obscured to where it's situated lower than the 20th most brilliant. It was truly confounding to notice its shadowiness. Conversely, with its adjoining star Aldebaran, which holds the 14th position concerning splendor. Luckily, Betelgeuse offered hints of improvement. Anyway, its uncommon way of behaving didn't stop. As a matter of fact, it is presently showing a state essentially more odd than basic. Diminishing over recent months, Betelgeuse has gone through a profound expansion in brilliance. outflanking its ordinary brilliance by a stunning amount. This astonishing situation is very problematic for a star known for its changes. The darkening occasions could be brought about by dust or matching cycles, or maybe the star created colossal sunspots. At any rate, a basic expansion in brilliance is something different through and through. Regardless of the way that it might be associated with the previous event when Betelgeuse removed material in late 2019, it likely caused a critical aggravation in the star's plasma stream. The current behavior we notice could be considered a postponed repercussion of that release. But what lies behind this remarkable way of behaving, beating the star's typical changes? One moderate hypothesis that has been broadly talked about is that Betelgeuse is moving toward the supernova stage, while moderate estimates still propose that the star is about a long time from the present supernova event. We will provide proof to investigate this idea and show that it has previously happened. So, what is the verification? According to a fantastic late logical paper by Hideyuki and partners of Tohoku University in Japan, Betelgeuse has currently gone through a supernova blast, and we may be seeing the repercussions of this gaudy occasion in something like 10 years or a few years from now. Yes, that is right. As amazing as it sounds, the last seen supernova in our world was the Kepler supernova, which was as far back as the 1600s. Through a careful appraisal of Betelgeuse's changeability patterns, the experts have seen 4 particular intermittent changes happening at time frames of 2,200, 420, 230, and 85 days. While the beginning of the longest period remains dark, it is assessed to be the pivotal period, with the more restricted spans potentially filling in as clues. The experts propose a model recommending that Betelgeuse is in a late period of carbon consumption, deducing that it may be almost an enormous impact, positioning it as a striking competitor for the next expected supernova event inside our Milky Way galaxy. Concerning unraveling the mystery surrounding Betelgeuse, there's somewhat of a question. You see, there are some clashing perceptions with respect to the send-off of materials and the stars following recuperation. The general agreement inclines towards a mass release occasion, something not by and large endless for various sorts of stars, but on a more unassuming scale compared to our own Sunday. Yet here is the curve. Supernovae are a real article too. We actually saw one in a satellite system of the Milky Way back in 1987. So while it's possible that our assessments for Betelgeuse's supernova timing could be off, don't go arranging an outing around it right now. The interesting part is that Betelgeuse is currently intriguing to note. It has slipped behind the sun and won't be obvious in the night sky until at any rate August.